Welcome back to another lesson with Learn Math by Example. Today, we're going to have an additional example to help you understand ambiguous case. Imagine this. A search and rescue drone operating is working from two ground stations A and B, located 10 kilometers apart. From station A, the operator detects a distress beacon. The angle formed by the line of sight to the beacon and the line connecting station A to station B is 30 degrees. Crucially, the beacon is known to be 6 kilometers from station B. Now, here's the mystery. Can the operator pinpoint the beacon's exact location, or are there multiple possibilities? It's a classic IB math scenario where ambiguous case of Sine Law comes into play. Over the next few minutes, we'll solve our drone location mystery. So let's get started. In our previous lesson, we've shown all the ambiguous cases. You can go and watch that lesson if you haven't done so yet. The link is in the description below. Now, let's solve our drone location problem using the Sine Rule and apply our understanding of the ambiguous case. So we have station A and B 10 kilometers apart. From A, the angle to the beacon, let's call it P, is 30 degrees. The distance from station B to the beacon, P, is 6 kilometers. We want to find the possible locations for P. First, let's find the height h. h is equal to 10 sine 30 degrees, so h is equal to 5. Since 5 is smaller than 6, which is smaller than 10, we deduce that the height h is smaller than A, which is smaller than B. And if you recall from the last lesson, this means that we have two possible solutions. Thus, we have two possible positions for the beacon. Now, to find these positions, we can use the Sine Rule. P of B over sine A is equal to AB over sine P. Substituting our known values, we get 6 over sine 30 equals to 10 over sine P. Now, let's rearrange to solve for sine P. Sine P is equal to 10 times sine 30 divided by 6. Since sine 30 degrees is 0.5, this simplifies to 5 over 6. To find angle P, we take the inverse sine of 5 over 6, which we call it arcsine. Don't forget, sine inverse can be represented as arcsine or sine as if it's to the power of -1. This gives us approximately 56.44 degrees. Let's call this P1. Now remember, the ambiguous case, if sine P is 5 over 6, then there's another possible angle for P. The second possible angle P2 is 180 minus P1. So P2 is 180 minus 56.44 degrees, which is approximately 123.56 degrees. Now, for each of these possible angles for P, we can find the third angle, angle B. For the first triangle, with P1 as 56.44 degrees, angle B1 is 180 minus 30 minus 56.44 degrees, giving us 93.56 degrees. Now, using the Sine Rule again, the distance from A to P1, or AP1, is 6 times sine 93.56 degrees divided by sine 30. This calculates to approximately 11.97 kilometers. For the second triangle with P2 as 123.56 degrees, angle B2 is 180 minus 30 minus 123.56, which gives us 26.44 degrees. Similarly, the distance from A to P2 is 6 times sine of 26.44 degrees divided by sine of 30. This is approximately 5.33 kilometers. So as predicted, there are two possible distinct locations where the distress beacon could be, given the information. The operator would need additional data, perhaps from a third station, to pinpoint the exact location. So now we've mastered another example of the ambiguous case of Sine Law. Remember, it's that tricky situation in the side-side angle scenario. When the given angle is acute and the side opposite, it is shorter than the adjacent side, but long enough to form two different triangles. Always be on the lookout for these conditions, as they'll tell you to find two possible solutions. Just like our drone operator, real-world problems often have multiple possibilities until more information clarifies the situation. Keep practicing these problems to build your confidence and analytical skills. If you still have any questions or want to discuss a problem, share your thoughts in the comments below. Engaging with the material and your peers is a fantastic way to deepen your understanding and analytical skills in mathematics. You can also check our previous lesson about sine law, cosine law, and ambiguous case to fully understand its visual representation. To check your understanding right now, head over to our website to have an additional practice and test your skills. Thank you for learning with us, and see you in the next lesson.